Oh, I forgot to turn the camera on. Okay. So.
Wait, let me try again.
No, I think it's okay. I think you can do it. Alright, so what happened here? I said 1/2 times 1/3, right?
Yes.
Okay. So what does that mean? That means, put an arrow right there just for fun. Over 1/2, up 1/3. Over 1 of 2, up 1 of 3. Here I have over 1 of 2, but I'm up 3 of 3. That's the whole thing here. So, look. Now, look. I'm going to cover this right here. And now we can see I'm over 1 of 2, and I'm up 1 of 3. And I get, what'd you put?
You multiply.
Yep.
2 and 3. That makes 6. Same thing. That's 1.
Okay. So understand though that you're not just doing multiplication 2 times 3 and 1 times 1. No. What you're saying is you actually have 1 of 6, 1/6, right? Because people ask, why when I multiply does it get smaller, and why when I divide do they get bigger? Showing that they have an utter lack of understanding of fractions. That's fine if it's you or your classmates or students, but it's not fine when you're a teacher.
Yeah.
What we're doing is counting. Over 1 of 2, up 1 of 3. Literally. This is 1/2 taken 1/3 times. Nobody got smaller, nobody got bigger. What we did is counted out 1/3 of a half. You see that? And this is 1/3 of that half. You see it?
Yeah.
I took my half and cut it into 3 pieces, and 1/3 of a half is 1/6. Now, we don't have to spend much time over here, but see, this is what confuses kids, is because, well, when you multiply, it's the same rules as always. You just multiply straight across. But when you add, what do you have to do? What's the name of the game when you add?
The same of the game, the name.
The same is the name of the game when you're adding.
Same is the name of the game.
Right, and subtracting, right? And actually when you divide, too.
Yep.
Yep. Okay. So, could we do any of these? I mean, I can put any numbers here now. But let's just do a couple so people can see.
Yeah.
Okay. Alright, so a new problem. 1/3 times, or 1/3 times 2/5. Right?
Yeah.
1/3, 1 of the thirds kind times 2 of the fifths kind. So what kind are we going to get?
15.
15th kind. First off, we know that for a fact. How many of the 15th kind are we going to have? Well, first off, how do I get 15? Well, I got to use this.
Yep.
Okay.
And you got to cut the...
Right, okay, now we got to cut off because we only want, right, we want 1 of the thirds kind, but then I have 2 of the fifths kind. So I'm going to go up 2 of the fifths kind. You see, 1, 2, 3, 4, 5. Out of 5, I'm going to go up 2. So I'm only going to go
like this.
Right, that. There you go. And I'll cover this part so nobody gets confused, right? Put the child in a situation where they can't fail. Boom! There it is.
Bing, bing.
Easy, right?
Bing.
Now, later on, we're going to run into some kind that we're going to reduce, right?
Yes.
This was self-directed. This was, I told her, make any problem she wanted, and this is what she did. Okay, so if I have 1/3 times 2/5, I get 2/15. So, if I have 1/3 of 2/5, 1/3 of 2/5, I get 2/15.
Yeah.
So in other words, if I had a box that was 2/5 full, and I used 1/3 of it, that would be 2/15. Okay, pretty simple. There it is. Right? And the way to explain this to little kids, and sped kids, and kids who climb on rocks, and any kids, and adults, is look, I'm over 1 of 3, and I'm up 2 of 5. Simple. And I get 2 of 15. Easy, right? Alright, no manipulatives this time, no materials.
Okay.
What do you get? Easy.
Oh.
Okay. Now, can I reduce this?
Sure.
To what? Alright, Crewton Ramone's House of Math for more. Quick lesson, yeah, Crewton Ramone's houseofmath.com. Quick lesson on multiplication of fractions. Okay, so we're on our way to discovering why invert and multiply. So let's see here. We're doing division now. And when I put the symbol here, she had a hard time with it. Because they weren't the same. We'll talk about that in a second. How many quarters are contained in a half? Some people say, well, when we divide fractions, they get bigger. Nothing's getting bigger. I'm counting how many quarters are in a half. 1, 2 of them are contained in a half. Now this is impossible to do because why? Well, they're not same. The only time they don't need to be same is when you do fractions. There's a reason for that. But now, oh no, phone. Now, we're going to have to do two quarters. See that?
Yeah.
So if I have 2 quarters, well obviously 1 quarter is contained in 2 quarters 2 times, right? We made them same, now we don't care about the denominators, we care about the numerators, we care how many of these are contained in this one. And the answer was of course 2. Now when I do this, she remembered the rule that you just invert and multiply. 1/2 divided by a quarter is the same thing as 1/2 times 4 over 1. So how do we get that rule? What do we do? Some people can see the shortcut right away. Some people need more examples. I'll give you more examples. Does it make sense though?
Yes.
That what I'm doing is I'm counting out how many of these are contained in here. And there it is. But what if we have 2 numbers that are less obvious? Let's see what happens. Alright, trying to get the concept of why invert and multiply. So 1 quarter is contained in 5/8, 2.5 times. And we could see that. Okay, but first we have to make them same, right? Right, where's the pen? So do me a favor and make that one same. But wait, before we do that, let's look over here. Let's get this over here. Oh, got all these 8s. Because I have 5 8s, right? And can you see that an 1/8, 2 8s is the same thing as 1 quarter? So we really were just counting out how many quarters in 5/8? 1, 2, and 1/2 of 1. 1, 2, and 1/2 of 1. You can see an 1/8 is 1/2 of a quarter. Alright. We can really see it. So, again, if we count them and make them same, it makes it a lot easier to do the math. So let's make this same. What do we get? 1 quarter is the same thing as how many 8s?
It's the same thing as 1. Same thing as 1.
1 quarter is the same thing as how many 8s? We have to change this into 8s.
Same thing as 2.
Yeah, there you go. So write it. You can see it. It's the same thing as 2 8s. So write down 2 8s. Just cover it. Don't worry. I don't worry about my pens the way you worry about your pens. Cover this one. Just get rid of that. Just put it. She has this thing about not mixing the pens. Okay. So it's 2 8s, right? Is the same thing as a quarter. Now, can you see that now that we have 8s, I'm saying how many, right? Here, the 8s now are just along for the ride. The kind is same, so I can say how many 2's contained in 5? 2.5. And I can really see that, right? 2. If I get these guys out, because you'll see that we did more in a second. 1, 2, and 1/2 of 1. But if we do our shortcut, where I take 5 8s divided by 1 quarter, you can see that if I just invert and multiply, I get 28, which is the same thing as 2 and 4 8s and 2 and 1/2. Yep. We were counting out how many 8s are in 20, because every time I get an 8, right? Every time I get an 8, that's 28, right? This would be 1/8, right? Can you lean back a little bit? You're in the light. There you go. Now, if I have this as an 1/8, I have 20 of these 8s. Every time I get 8, that's 1, right? The 8 tells me what kind, what the 1 is. And that would make 1, 2, right? And 4 8s. And then we figured out that 4 8s is exactly the same thing as a half of that, right? But look at this, Where's my green pen?
Right here.
The green pen.
Right here.
Oh, there you go. Okay, thanks. Okay, but look at this. Watch this. If I know about cross-canceling, this shortcut over here, punk, doesn't that become 1, and this becomes 2? And look at that. There's my 5 over 2. There's my 5 over 2. Right? See the shortcut? All that invert and multiply thing does is give you the shortcut. See how it works? And then I could go straight and I could say 5 over 2 is the same thing as 2 1/2 and skip all this part in between. Right? So that one, being able to do that part makes life a lot easier, doesn't it?
Yeah.
Alright. Crewton Ramone's House of Math. for more. Righty. The last example. Okay, right? So we stretch with the other one, and then we come back to this one. How many times is 1/5 contained in a half? And then we've got all these blocks over here and all these manipulatives. Alright, so look. Here's a half, and these are fifths. So I can see 1, 2, nobody's getting bigger, we're counting. 2, and you can really see that's a half of 1. So the answer is 2 1/2. And look, so we make them same. Once we make them same, I can start counting. Look, there's 2 is contained in 5 how many times? Right, 2 1/2. Okay, so now we see our shortcut. Here is 1/2 divided by 1/5. And what they say is, what's the rule here? Tell me, can you remember? Invert and multiply. Look, well, when I invert and multiply, there's my 5/2 again. Oh, there it is. That's why you invert and multiply. It's a shortcut. But see, what happens when you take the shortcut and you don't know the long road and you don't know what you missed. Right? You take the shortcut. Usually, people take the shortcut after they've taken the long road, right? If you don't want to take the scenic route because you live there, right? Okay. So over here, I have 1/5 contained in a half. Could you write 2 1/2 right here, please? I don't know, where's the pen? You got it. Because it is 2 1/2.
Hold on.
And then over here, this is 2 1/2, right? 2 is contained in 5, 2 1/2 times. And over here, we see, there it is, right? Without having to make the tens, right?
Yeah.
Don't have to do all the stuff with making them same with the tens and so forth. We just get the 2, 5, right? There it is. 2 is contained in 5 how many times? 2 is contained in 5 how many times? 2 1/2. That's it. Right? And and then here's our last example using the blocks, making sure that we could see that 2 is contained in 5. Remember, we did that, and if you watch back at the beginning videos, we'll see that I have 5 of the halves kind, right? So I'm saying each one of these is a half. There's 5 of them. Every time I get 2, that's 1. Right? See how it all goes together nicely? Right? From the first time we started this? Okay, so there it is. Addition, subtraction, multiplication, and division. Super easy. Crewton Ramone's houseofmath.com for more. Okay, quick addendum. Just a fast one. No symbol, or excuse me, no blocks, no math materials, no tiles or anything. Just symbols. So here, not same. We had to make them same. Oh, can you see? Oh, look at that. Right? Made them same. Right? We had to multiply. And those of you who are advanced can do this in your head, but the little kids might need to see. They have to multiply by 3/3 here, and I have to multiply by 2/2 here to get 12ths. Right? And then you see, 9 is contained in 2. Right? And that's all we can do, right? Is this. Right? Now we do over here with our quick shortcut method, which actually turns out to be a little bit of work, but it gives you the exact same answer. Look at that. So here we just do the invert and multiply, right? I did some cross canceling. She did it straight out so that she had to do the reducing. If I did the cross canceling, oh, there it is again. Right? 3 times 3 is 9. 1 times 2 is 2. Oh, that's why you invert and multiply. It's the shortcut to making the same. And see over here, I didn't have to mess with the making 12s, right? It shortcuts this. Now, some of you may take a look at that and figure out exactly why we invert and multiply, but there it is. There's the basic concept behind it. So instead of having to make 12s and stuff like that, we just go directly to 2 9ths. Or, in this case, we had 4 18ths and then we got to 2 9ths. But there it is. I mean, very clearly. You can see it. Okay, Crewton Ramone's House of Math for more!